So welcome back to your favorite inorganic tutor YouTube channel. Today is another episode. We want to look at how we can deal with these particular functions when they are given in the natural logarithm form, right? And want to look at how we can find their derivative. All right, so here let's look at this particular problem. We are going to look at 5 basic questions, right? They are not going to be tough. Some of them will be tough, but I'll give some to very easy as well, so that you can enjoy the lesson. So here, let's take our first example, and then that is y equals ln into s cubed minus 2. Right, so this function, we want to find the first derivative of this particular function. Of course, you can go ahead and find the second derivative as well if you get the mastery of how to find the derivatives, right? So here, we know that the first derivative, which is represented by this, which is the same as the y over the x, will be equal to, the idea is that if you have a natural logarithm is the same as log, right? So you take 1 over the function, the inner function, right? So we have 1 over the inner function, and that is s cubed minus 2, right? And then we differentiate the inner function again. So we have the differential of the inner function, which is s cubed minus 2. Very, very simple. So this is how we go about it when you have a function like this and you have to find the derivative. So dy dx, which is the same as the y prime, will be equal to 1 over s cubed minus 2. Then the differential of this becomes 3s squared. This comes down and they take 1 from the exponent. And this, of course, becomes 0 here. So we have minus 3s cubed minus 3s squared over s cubed minus 2. And this becomes our final answer for this particular question, right? So we can try another example too and see how it's going to alternate with different examples. So our next problem is going to be y equals ln of s squared over a. Right. So this is the problem at hand. I want to find the derivative of it. Right. So finding the derivative of this particular function, we all know that this is a constant. Right. So if this is a constant, then what can we do? Right. So we take 1 over the function inside the inner function. So we have dy dx, which is equal to this, right, will be equal to 1 over the inner function, which is s squared over a times the differential of the inner function, which is s squared over a, right? So here we can deal with this thing and simplify it very well to make the work so nice. So we have 1 divided by x squared over a here. Then the differential of this, right? We know that this can be written as a inverse, right? A inverse, or let's maintain it that way. Let's maintain it that way and use the quotient rule, right? So maintain it that way, and we are using the quotient rule. So this becomes differential of this, which is 2x. Then maintain the a minus the differential of this, which is 0. Then s squared all over this squared, right? So we have this becomes s squared over a, then we have 2ax, and of course this is equal to 0, and okay, yeah. This part is actually going to be 1 times a over s squared, right? So systematically, this is going to be 2ax minus 0, all right? So over as, which is a squared, right? So here we have a over s squared, and then we have 2ax all over a squared, right? So we can take off one of this here, and we are going to have dy dx equals a over s squared times, when this takes off one of this, we're going to have a here, then this go, so we have 2x over a. Yeah, so we can still go ahead and cancel this a off, and then we have dy dx. This takes off this, and we have, and of course this is going to take one of this, right? So we have 2 over x as our final answer, and that is very simple, but it looks like it needs a little bit of techniques, your algebra here. So this is basically the same way as 2x power minus 1, of course is the same thing, right? So we have this here as our final answer for this particular function. So just have to learn the techniques for your operations and your algebra, and then that's will get you there. So let's look at our third problem. Right, our third problem here. Our third problem is len 2x minus 3. Right. So we are going to use the same ideas that we used for the previous works, right? So here we say that dy dx, which is the same as this, will be equal to 1 over this, right? The inner function, which is 2x minus 3. Okay, right? So we have 2x minus 3 here, times the differential of the inner, right? The inner function, which is dx into 2x minus 3 here. Good. So this, we can go ahead and say that this will be equal to 1 over 2x minus 3. Then the differential of 2x minus 3, we all know that this will go to 0, and this basically be x here. All right, so we have 2 rather here, so we have 2 here. Of course, this will be 1 minus 1, that is 0. Any number power 0 is 1, so we have 2 here. And then this becomes 2 over 2x minus 3. And this becomes our final answer to this particular problem. Very, very easy, as you see. Now let's look at the next example, which is example 4. Example 4 on how to use the derivative on the natural logarithm functions. Right, so our example 4, which is len x, right? So we are given len x, and we have to find the derivative, the first derivative of this particular lane x, right? So the first derivative, right? The first derivative, which is equal to this, we all know that the same knowledge that we were using, we take 1 over this, right, times the differential of the x, right? So we have the y dx, which will be equal to this, right? We know that the differential of x is going to be 1. So we have our answer to be 1 over x as this. Very, very easy. Left with the last example on this particular topic, and we are down the line. Okay. So our final example is going to be ln into 2x minus s cubed. Yeah, I think minus s cubed all over x power 5. So it looks complex, but it's not anything difficult beyond your standard. So let's look at how we can deal with it. So we know that this, okay, so here will be equal to, we know that this, of course, when we have this, is the same as, okay, so let me write this here first. This is the same as ln into 2x minus s cubed all over ln into so when we have this, then we can have the minus, right? So so here we can say that this is the same as ln into 2x minus s cubed minus, right? Because we are applying the law of logarithm here. We already know that log a over log b is the same as log a minus log b, right? So we are using the same principles or properties over here. So if this is true, then the derivative of this here is going to be, as usual, 1 over 2x minus s cubed, then the differential of the inner, right, which is going to be dx into 2x minus s cubed here, minus the 1 over s cubed, s power 5, right? Then the differential of the x power 5, right? So we have 1 over 2x minus s cubed. Then the differential of 2x minus s cubed is going to be 2 minus 3s squared minus 1 over x power 5. That's of course this. Then the differential of this will be 5s power 4. Right, so this, we can now expand this, spread it, and then we can have our final answer. Right, so here we can say that y prime, which is the same as dy dx, is equal to, now we know that this is over 1 here, and this is over 1, 2. So this will come up, and this will go down, right? So we have 2 minus 3s squared all over this 2x minus s cubed, right? Minus 5x 4 all over x power 5, right? I think this is already simplified, or we can go ahead and say that this is equal to 2 minus 3x squared over 2x minus s cubed minus 5x 4 all over x5, right? So we can look for common denominator here, right? So this will take off this and we have this remaining s5 into 2 minus 3x squared minus this taking off this, and then we have this. So we have 5s4 into 2x minus x cubed, right? So you can as well expand this, and then of course this looks a little bit um, tedious, but it's not very simple, very simple. So we have dy dx, which is equal to 2s5, right, minus 6x7, right, or 3 rather, we have 3 here, so right, good, minus 10x5, then we have minus plus 5x7, right, all over 2x 6. Yeah, spreading this s power 5 to all of this, so we have minus x power 8 up here. So now we can add the common terms, right? The common terms. So we have dy dx, which is of course equals this and this, right? Okay, we have 5 here and we have 3 here. So we can say that 5 minus 3 x7, and then we have plus 10 plus into minus 10 plus 2 x5, right, all over 2x6 minus x8. So we can take this work on this operation, and we have 2x7 minus 8 x5 all over 2x6 minus x8, of course. And this can be our final answer because of this, we have nothing to do with it again. So this is our first derivative of this particular function. Of course, it looks plenty, it looks so many, follow the procedures and you can get it done very easy. So here, if you are asked to find the second derivative of this particular function, we all know that as usual we're going to use what we call the quotient rule, and it's going to be a lot of work for you, but you can do it. Thank you very much for watching. This is a very simple tutorials for how to find the function, the first derivative of a function in the natural logarithm form. All right, so our next is going to be how we can deal with the inverse of a function using the how we can find the derivative of a function using the y, which is the y constant, right? How we can find the derivative of these particular functions, right? So it's very simple. Thank you very much for watching and have a good time. Bye.